Hello students, this is Mr. Parrish. So the test is tomorrow. I thought I'd walk you through one problem that would be pretty important to understand for your test. I think most of you know how to do this, but just as a quick refresher, this problem is going to be using stoichiometry to find the liters of a gas produced. So this is on page 33 in your packet, so you can find this yourself. This is question number 36. I know some of us have already attempted it, so you can just double check your work. So the problem is, there you can read it. It says that you have a gas being produced. This is, I think it's called acetylene. Yeah, this is acetylene gas being produced. So this would be the gas being produced here. And what you're given is you're given the grams of water in the reaction initially, and they want you to find the liters of acetylene gas produced. Okay? So the first thing you have to do is find the moles of acetylene being produced. And how we do that is, of course, by using our stoichiometry, going from grams of one substance to moles, and then moles of another. So I'm going to set that up for you really quickly. You're going to take your 2.54 grams of water. You're going to multiply by a fraction. You're getting rid of grams, so it goes on the bottom. And you're going 2 moles, so it goes on the top. In 1 mole of H2O, there's 18 grams of water. That's the molar mass of water that you can look up on the periodic table. When you multiply by another fraction, you want to get to moles of acetylene, so you put moles of H2O on the bottom, because you're getting rid of that, and then moles of C2H2 on top. Now remember, when we're going from moles to moles, you have to use the coefficient of the reaction. You're given the balanced equation, so you can see that the coefficient of H2O is 2, so it goes down here, and the coefficient of acetylene is 1, so you put that there. So when you multiply across, and remember you would just put the fractions in exactly as they appear, you would get 0.071 moles of acetylene, so C2H2, being produced. Now that you have the moles of what is being produced, so that's the first step, you need to use PV equals nRT with the pressure and the T given to find the volume. So you're going to try to find the V. So you have PV equals nRT. So you get P from the question, you get T from the question, which of course we always convert to Kelvin. And then our V is what we're looking for, and we get our N from step 1. Okay? So you just want to plug these numbers in, and you're going to get, can you still see me down here? Okay. You're going to get 742 millimeters of mercury times V equals 0.071 moles for the N. The R constant, because you're using millimeters mercury, if you look on the periodic table, it's 62.4. And then the units for that are millimeters of mercury times, I think it's liters, over moles times Kelvin. And remember, this is just a unit. This is not a formula that you plug into. And the temperature is 299 Kelvin. Okay? So now we got to solve for V. So we multiply all of these numbers together, and you should get 1324.69. And that's going to equal 742 times your V, which you're still looking for. To get V by itself, and this is where a lot of you sometimes mess up, you need to make sure that you go ahead and show this step like you would in algebra. Okay, a lot of you guys are flipping this last fraction, and all the multiple choice problems have both options, both the fraction flipped and the correct answer. So make sure you follow this last step and make sure you cancel out 742 on this side to get V by itself. And you should get the volume of the gas as 1.79 liters of C2H2. Alright, so that would be your final answer. Feel free to share this video with your friends via social media. I want to get the word out. Make sure that you know how to do a problem like this on the test tomorrow. It'll be really helpful. Okay? Have a good night. Study hard. Call me if you need help. Thanks.